Morning to all the participants. Welcome to the day 4 of our national level FDP on integrating AI deep learning for biomedical processing, a MATLAB approach in collaboration with MathWorks and DesignTech system. For the day 4, we will be focusing on the topic integration of AI and ML for biomedical application. We have with us today as a speaker Mr. Kunal Khandelwal, who is an application engineer, MathWorks DesignTech System Private Limited, Pune. Welcome, sir.
Well, good morning. Thank you, ma'am.
On behalf of Department of E&TC, T.Y. Patil, Pimpri, I welcome Kunal sir. Sir is a seasoned application engineer at MathWorks DesignTech System Private Limited. He supports education and government clients by delivering training and technical expertise in MATLAB and associated products, focusing on areas like image and signal processing, data analytics, machine learning, and AI. He is also skilled in deploying models on hardware such as Raspberry Pi, GPUs, and other embedded platforms. Sir has hands-on experience with hardware deployment and optimization, helps clients accelerate their workflow, integrating advanced algorithm into real-world application. We are happy to have you with us for the day 4 session today. We will start with the session, sir. Over to you.
Thank you, ma'am, for the warm introduction. And good morning, dear participants. I had shared the link with you for today's demo course. I hope you are able to access it. If you have not received it, just let me know. I would share that even in the chat, Zoom chat, so that you may have an access to it. And then we will start with the session. Yeah. Yeah, good morning, one and all. Okay, shall I share the link with you also before we start?
Yes, sir.
Okay, okay. Sure, ma'am. Sure, I will do this. Okay.
Participants, please make a note. Sir has shared the link in the chat box. Also, he has shared it in the WhatsApp group. So you can access it wherever it is possible for you. Please download these files at your system.
Okay, let me share my screen. Please, ma'am, if you will acknowledge, if you all are able to view my screen. Is my screen visible?
Yes, sir, it is visible.
Okay, right. Okay, let's look at chat if someone has any query. Okay, thank you, sir. Thank you. Okay. So we have divided today's session. Okay, let me close the things which we do not require. We can get it later on. Okay. So we have divided today's session in two parts. Okay, before that, in today's session, we are going to talk about how to use MATLAB's Experiment Manager app. And this session would be divided into two parts. So in the first session, we are going to have an overview of how Experiment Manager can be used for classification, which is a general purpose classification. Okay. And in the second half, which will be post lunch, I will take you through how Experiment Manager can be used with biomedical images. Okay. So that's how we have divided it. If you feel you have any doubts, anything, please put that into Dropbox. I have my colleagues Ankit and Rohit join over here who can answer your queries. Okay, let's move ahead. Fine. This will be the basic overview. I'm quite sure that Ankit and Nikhil has already covered with you fundamentals of MATLAB and Simulink. What is deep learning? They might have also focused on how to use MATLAB's Deep Network Designer app to train AI models interactively. I am going to have a quick recap of what you might have done, okay, just to set up the foundation. And then we will move to design and run or compare deep learning networks with Experiment Manager app. Fine. So by the time I go through the overview and cover the fundamentals, please try to download the files. And if you're using MATLAB online, you already know how to copy the folder and use it for your purpose. Fine, let's move ahead. MathWorks have two flagship products, MATLAB and Simulink. So MATLAB is basically, used for algorithm development, numeric computation, data analysis, and visualization. If we talk about Simulink, it's a leading environment to create models and implement dynamic systems. Now you'll find out that people are moving ahead and they have started using AI with Simulink. Let me see if I have an opportunity to showcase you one of such examples. I will try to showcase you all. I hope you all are aware about MATLAB and Simulink. Let's continue further. Now, this is the technical computing workflow. Let's try to understand this with respect to signal processing or DSP or image processing, things for it. So on the left hand side, you can see we have something known as access and acquire. So we require data. Now data could be available in real time using hardwares. So this could be electrodes or this could be cameras capturing the images, or there would be text files, CSV files or spreadsheet where data would be present. Next, we need to build up a pipeline where we explore the data, we analyze the images or signals, we try to work on the data so that we can remove noise, we can remove trends, we can build a small prototype, and later on what we try to do is we try to share and deploy it. Okay, so there are a few of the things that we'll be talking about in this particular session. Fine, so we have discussed this, right? Now, before I move ahead, let's try to recall the deep learning workflow with MATLAB that you might have seen earlier. So the first part is access and explore data. You might have already covered this. Ankit and Nikhil have covered this part. Labeling and pre-processing. I'm quite sure Ankit has shown you a few labeler apps for image and signal. Okay. Next is to develop the predictive model. So where are we starting today? See, if our model doesn't give us better accuracy or better performance metrics that are desired, we often go through parameter tuning, right? So this is an iterative process where we try to find out our best model. So we are going to start with this hyperparameter tuning today. Now to help us out, we have certain apps. What are these apps? So to increase our productivity, MATLAB provides you apps. These apps are Deep Network Designer app, which you might have already utilized to build up certain models. Okay. And then we have an Experiment Manager app. Experiment Manager app will help us to manage multiple deep learning experiments, analyze the result, okay, view and compare the results, and also generate the code. Let's try to move ahead and let's try to understand why we want to do this. So as I was discussing, you may think of that your AI model, the CNN model, which or LSTM model for regression or classification task that you have built up is not providing you a accuracy as desired. So you may think of improving the results, and we'll start with this. So this is a part of humor, and you can look at this image and you can try to find out what exactly is happening over here. Fine. Okay. Let's start. if your neural network is not giving you desired result, you may think of certain questions, and we will definitely like to answer these questions. This may be with respect to the data set that we are using. This may be with respect to the neural network architecture that we have built up, either pre-trained model or our own CNN model that we might have built up from scratch. And yes, with respect to parameters and the settings. With respect to data, the questions would be, do I have enough data? Is this the data that I was looking for my applications? Does data set require pre-processing, which could improve the quality of the data? Does it require data augmentation? When we talk about neural architecture, we talk about which layers we want to use and why. Okay. Have we provided normalization? Are we going to go with our own model from scratch, or we are going to go with pre-trained model? This leads us to parameter and their settings. What were the parameters that were present when we were trying to train the model? What was the batch size? What was the learning rate that we have set up? What about the weights and other values? What about the performance metrics? Are we going to work on custom metrics? So this leads us to few things. Okay. So here you can see when you talk about parameters. So we say that the challenge with the parameter is there that there is no such number that will work everywhere, right? So the best settings or best numbers will always depend upon each task and each data set, right? So this would be certain parameters that we are listed over here is what solver we are going to use. We have three solvers, SJDM, ADAM, and RMS prop. What would be the initial learning rate? Am I going to keep it too fast? So 0.01 is fast. What about 1e to the power minus 5 minus 4? Would it be too slow? What about a number which is midway between these two values? What about mini batch size, epochs, and validation frequency? And are these parameters going to play an important role in improving the accuracy of my model? We need to find out that. Let's go ahead. To do this, we are going to use the Experiment Manager app. Okay. Now, what does Experiment Manager app provides us with? So before I go ahead, let's go to the MATLAB documentation and let me know if you are able to, okay, you are able to access the codes because we'll be starting with hands-on. So if you go to Experiment Manager app, what we find out that Experiment Manager app can be used to set up our experiment quickly. It has a pre-configured template, right? The template works well with the workflow for image classification, signal processing, and semantic segmentation. Now, we are going to go ahead with this, okay? So please let me know, are you able to access MATLAB Drive and the codes? So these are the codes that I have shared with you. Okay. Please let me know if you are able to access these files, okay? That will help me in understanding with the hands-on session.
Yes, sir, it is accessible.
Okay. Thank you, ma'am, for your confirmation. Okay. Thank you. Please launch your MATLAB. You can launch your MATLAB. You can navigate to the folder. Okay. So those who are using MATLAB online, for them, what we could do is you can go to MATLAB home, click on open in MATLAB online. I hope you have copied the folder. Okay. So for those who have clicked on the link, you might see an option over here, copy to my files. You copy it, it will get copied. This has already been covered by my colleagues earlier. Okay, go to MATLAB. In MATLAB Drive, you should browse to the folder. So this is the folder name. In this folder, you have this 04 experiment manager. The second example is a different example. We'll come to that later on. Click on experiment manager. Okay. And before we actually start with the experiment manager app, we are going to have a quick recap. So click on this file, experiment using deep network designer. I hope you are able to access this file. I'll change my layout.
Yes, sir.
Thank you, ma'am. You can change your layout and you should be able to see somewhat like this. This is just a quick recap for our better understanding that we are going through this particular file. Okay. So what exactly we want to do? Let's try and understand. This file is divided into two parts. So to improve this, I'll show you in live task, you have an option. You can go to live editor. In live editor, you can go to task. Okay. Or you can go to insert button and you can click on table of contents. So this will add the headings which are present in our file to have a better overview of the file before we access it. So as I told you, this particular example is divided into two parts. In first part, we are going to train our model. And in the second part, we will look at some of the shift example which are present with the MATLAB tool. Let's go ahead. So what are we trying to do? In the first example, we will use experiment manager to tune the hyperparameters either for a regression or a classification. We will decide how we are going to go ahead. Okay. And then we can use deep network designer app to create a network, import a data, and so on. So two tasks are there, as I told you. Task number one, you can use deep network designer app to create the network, import the data, and train the network. Task two, you can then use experiment manager app to sweep through a range of hyperparameter values and find the optimal training options. So these two apps would be very, very useful for the researchers who work with images, signal data, okay, video data and all that. Let's move ahead. Let me explain you the first part. Then we'll execute the code. And then we will move with the experiment manager app. Let's start. So the first step is to load the data. Now from where this data is coming, don't worry. This data is already available with the shift examples. And that's the reason you do not see any data in this particular folder right now in files. Okay. So what we are trying to do is we are trying to use a data set which consists of 10,000 images. Okay. Which are grayscale images of handwritten digits 0, 1, 2, 3 up to 9. If you talk about size of the image, it is 28 by 28 by 1 pixel. So this indicates height and width is 28 by 28 and 1 indicates it's a grayscale. If it is 3, it's a 3-channel image, which is an RGB image. Okay, let's move ahead and let's try to load the data. So we are loading the data, right? Okay, then we will split up the data into validation. And here, what is our aim? Our aim is to train a regression model to predict the angle of the image, right? That's what we are trying to do. In the second part, step 2, we are going to build up the network. So here you can say you can build up this network by using Deep Network Designer app, or if you feel that you are better at writing code, you can go ahead and build up it accordingly. I'll show you this how to build up the model, okay, in the Deep Network Designer app and export it later on. What is next? You can view if the model layer by layer in Deep Network Designer app, if you have written it in the form of program. So this is a programmatic approach. If not, we will build up, and through this export app, we'll try to export it from the Deep Network Designer app. Next, we will train the network. So while training the network, you can see I have kept over here minimum training options. Solver is Adam. Okay, we want plots. So in plots, we want training progress. Okay, verbose is false. Metric that I am interested in. So this is for regression. So the matrix I need is RMSE. Right? And I need to provide the validation data over here. So this validation data is nothing but combined data store validation that we have, created earlier. Next, we train the model and we should get a graph something like this. Okay, so this is the first part that we are going to do, right? Okay, let's move ahead and let's try and execute the code. So before I move ahead, just let me know, okay, that you all have access to it, right? Okay, fine. So to execute this is MATLAB live script. Wherever you see these numbers, line numbers 1, 2, 3, 4, 5, and so on, these are the code part. And whenever you see a text like this, okay, this is a text part. Let's try and execute section 1, load the data. So how to execute this section? So if you click in this particular section anywhere, this blue strip, vertical strip gets appear. You have to click on the strips. This circle over here indicates that the script is running, and this circle is not visible right now, which indicates that the execution has been completed. Now, since here the network is already built up, I'm not going to show you how to build up this network, but entirely, but I'll go to apps. So I was into live editor tab. I'll go to apps. From apps, I will try to search for Deep Network Designer app. So if you look at the category machine learning and deep learning, there are various apps that are being available to us. What I'm doing is I am launching Deep Network Designer app. So when we launch Deep Network Designer app, as I told you, we can create the model interactively, right? I am using the online mode. Okay. You can do the same thing, or if you're using offline mode, you can go with the offline mode also. Now, okay. So when you launch the Deep Network Designer app, there are various options to get started with. You may try to create the model from scratch. You can bring the model if someone else has trained it from workspace and import it. If you're using another framework like PyTorch or TensorFlow, you can bring the model from there. Okay. And if you feel like, you want to use some pre-trained models, so this is for images, you can use anything that is being required over here. Later on, if you want to go for LSTM, 1D CNN, they are available, sequence to sequence, and audio networks, Creepy, OpenGL, VGGish, YMNet, and voice activity detection net. I want to build up my own network. So click on blank network, that is new. Click on the layers. Okay. So if I click on the first layer, image input layer. So that's how we do it. As soon as you try to drag this image input layer, the properties of this layers gets appear on the right hand side. So what you need to do is you need to change the properties by typing this 28 by 28 by 1. And it is auto apply, as you can see. The property of the layer has been set. Similar thing can be done, okay, just by dragging and dropping. I'm not going through the entire thing, okay. Then you can take a batch normalization app layer over here through the app and so on. How to connect the layers? So if you hover your mouse or at any one of the layer, you can find out that the circle appears. Connect. You can click on fit to view or auto arrange. I'll click on auto arrange, and you can see that the network is arranged properly. You can keep on dragging all the layers which are mentioned over here. Okay, and once you do this, you need to click on export and export the network. In the earlier session, you have already done this, so this was a quick recap. We are not doing this. Okay, this was just to show you how we go ahead. I'll just close this. Okay, before this, do you have any doubt, any questions you want to ask? I hope this part is clear to you, right? Okay, there are no yes or no, so I hope this is clear to everyone. Let's close this. Okay, I don't want this, so I will execute this part. And later on, I want to look at the layers. So this line number 28, Deep Network Designer app layers, will launch Deep Network Designer app. And what you are able to see now, you are able to see the layers. You can zoom in, right? You can click on each and every layer to get the properties, right? View it. Done. What is next? If you want to understand whether the logic is correct for this or this particular layers that you have built up, you can quickly go to analyze. You can click on analyze. It will give you the workflow. So this is a part of a workflow where it gives you this line diagram for the layers. So we are at image input layer. You can go to the layers and you can check the properties. There is a drop down bar over here where you can click on number of learnables. So one more column gets added over here. Okay. So whatever you want to add, you can add it or you can delete it. Fine. So there are no errors and there are 17 layers over here. Fine. Fine. Okay. We have viewed this. Now there is an option. So what is an option? The option is I want to train the model. Okay. For this, I'm going to take the solver Adam. If someone wants to try this with any other solver, you can try this HGDM. So see, it gives you, auto suggestions, solver, plots, value, verbose, metrics, and so on. So if you want to use HGDM, you can use HGDM. I want to use Adam, so I'll use Adam over here. Let's train this. So the model. And let's try to look at the training progress. So the training have started. You can observe certain things over here, that here it is a single CPU. If I would have to train this model, okay, on my system, which has a GPU, so here you might have seen the hardware resource will be a GPU. How that is possible? So MATLAB has a parallel computing toolbox. The parallel computing toolbox tries to see if you have a better performing hardware over there. And if yes, automatically the training gets shifted over there. Slowly we are looking at that the training is being completed. So the number of epochs it took are 30. Iterations are, approximately 1200, I'll say. Right? Learning rate, validation frequency, and so on. Now, someone would say, are we looking at only this metrics? What if we want more metrics? See, if you feel like you want more metrics, I would suggest you go to training options, line number 29, right click on this, and you can click on help. So if you click on help, that will actually take you to MATLAB documentation, where you can see, the different things that could be done over here, right? So you can have this learn sheet radial. So it is written over here. It is learn rate. It's a piecewise. Learn rate drop factor is 0.2. So there are a lot of things that are being available. Okay. I am looking at some other metrics. Okay, wonderful. That's what I wanted. Let me share this in chat if any one of you wants to focus at this. Okay. So your question might be like, Kunal, you are showing us RMSA, it's fine, but if we have classification model and we want to look at some other parameters also, what could be the parameters? So these parameters are accuracy, F1 score, and loss. What if you want few more parameters? So you have to mention those parameters, okay, when you are building up the model under the training parameter. So if I go over here, you can find out under matrix, it is mentioned accuracy and F score. So loss is by default over there. I hope this makes sense.
Yes, sir.
Okay, fine. So then we'll move ahead because we are going to look at two examples, regression and classification. So we can try and do that. There are a few more things. Someone would say like stop training early using metrics. So why we want to stop early? So we want to stop early. Maybe, this is the best validation result I've got. I don't want to move ahead. Right? So after 5 iterations, I have got the best results. And I have got the benchmark, what I have set. So why should we move ahead and train the model? So for this early setting, you can go ahead, okay, and then you have to put a variable over here which says output network is equal to best validation, and automatically it will find out, okay, which is the best validation for you. So this particular documentation which I am showing you right now will help you further, okay, when you have a larger data and you want to reduce the number of epochs and iterations with whatever results you're going with. Okay, fine. If you want to understand what the solvers do, so see, each and every variable is mentioned over here. So you have HGDM, RMS prop, Adams. You can find out LBFGS, which is limited memory, Broaden, Fletcher, Goldfrapp, Shano. So this could be the name of the scientist. Short form is BFGS. It's also a kind of a solver. So here, whatever recent changes or updations are there, they might be mentioned over here for the new users. Okay, fine. What about ln? So this is Leeuwenhoek, Marquardt. This is also Selver, which has been added over here. You can go and you can find out everything, every detail in this particular documentation. Let me go to our MATLAB. We have trained the model, right? And now it's time for us to generate the experiment, which is step number 2. That is to use the experiment manager app. So before I do that, do you have any doubts, anything you want to ask? Shall we move to the next part, which is
If
experiment manager app?
participants have any doubts, they can ask, or else we will move.
Okay, I think most of them have mentioned yes. So I think
So
that
we will
this,
continue, sir.
yeah. So what we can do, take a break of 2 minutes. I am there in the meeting. Okay. Go through the documentation, read it once what we have done. So just to tell you, see, up till now, we have our own model, right? The model we have built up from scratch. So if you go back to the presentation, okay, I'll go one step back. Look at this slide. Not able to run. So, sir, you can do one thing. If you're not able to run, try to see if you have run this section. So if you're getting error in the later part, okay, which is 29. So 29 is talking about training options and CDS validation, right? So the reason might be that this particular CDS validation is not available. Okay. So what I was talking about, yes. So if you go to our slide back, we have enough of data. So this particular part is done. Yes, we are at this part. Like we have used the layers. Okay, we have got the results. But if I want to use other network for this particular purpose, how are we going to we use that? And also, we have used one set of parameter settings. We have mentioned the best size, learn rate, and other values. What if we want to change them, right? So to do this, just try to go to the documentation and observe what we are trying to go and do the next part. So the next part would be, we are going to launch the experiment manager app. Okay. So when you launch the experiment manager app, it will give an option. Do you want to open or you want to start with an example? So the examples which are shown over here are the examples. It's a shift example. You can take any example from here. I'm going to show you 2 examples in the first part, and then later on we are going to move to the biomedical images over here, right? Okay. Next, when you launch this, you will get a template. So this is the front end of the template. What does the front end of the template consist of? This is quite interesting. So as soon as we launch this, we have the project name. What's the project name? Digit Regression with Accuracy project. This is the name of the project. Then we have a file, which is regression experiment file, which is act as the front end. It has different sections, and each sections we have to write down either description or set up our strategy over there. So description is what, like, the earlier model which we have written over there was not giving us that better accuracy in terms of RMSE to predict the angle. So I want to create an experiment. So if I want to create an experiment and I do not have any other regression model, I will use the properties of the training part, that is the hyperparameters. So, or you can go to neural networks, and if there are convolutional layers, you can go for filters or strides over there. Okay, fine. So the number of filters used by the convolution layers, I want to do an experiment on this, and the probability of the dropout layer in the network. So if I scroll back, what you may find out, there are certain layers over here, dropout layer. And if you talk about convolutional layers, okay, over here, we might be using filters, and we want to understand that if we change their values, what would be the result. In this experiment, we have to build up a setup function. What is the setup function? So you can write down any name for this particular function. So name of this function over here, which we have set up is regression experiment setup. This could be any particular name. And in the post training custom metrics, we have mentioned over here accuracy. As we go ahead, okay, as we go ahead, you have an option over here to run, right? When you run this, you will find out that a table will be launched like this, and this table will have list of each and every combination over here. We can view the results, we can copy the results, and so on. So we'll do this first part up to run experiment. If there are participants who are ahead of me, you can go ahead, okay, adding all these other parameters, that is adding the solvers and so on. Okay, so let's take a break of 2 minutes, read the documentation, and then we'll start with the experiment manager app. If you have any doubts, anything, you can put into chat box. I'll be happy to answer them. Okay, so let me know if my screen is visible and we can go ahead and we can start.
Yes,
Gayatri
sir.
ma'am, yeah, thank you, Gayatri ma'am.
Sir, we have a query in the chat box.
Yes, I am answering that. Gayatri ma'am, you have to click again on the number 31. You have added a breakpoint. So you click on number 31 and then you have to click on continue at the top. Or if you want, you can share your screen. I can help you out, or I'll show you what you have done. Okay, just a second. Okay, so ma'am, what you have done is you have clicked on this number 31. Okay, like this. So if you go to light editor tab, this act as a breakpoint. So if you will hover your cursor on line 31, you will find out it says that you have created a breakpoint. So this will pause over here. So again, click on this line. Okay, go to this section and run again. Fine. Okay. Just a second. My Outlook is launching. I'll close it. I don't need it right now. Okay, fine. Any other queries?
Yes, Kunal. There is error in 30 number line, 31 number line.
Yeah, Ankit, I told ma'am what is supposed to be done. Thank you for your attention and help. Any other query? Okay, let's move with the important part because that will also further help us to move ahead. Okay, so as we go ahead, what we'll find out, I'll just let you know, I'll just close the windows that we don't need. Okay. From the apps, you can click on Experiment Manager app. So under MATLAB's tool strip, this section, you'll find out there are different apps used for different purposes. Our aim is to explore this Experiment Manager app. Click on this Experiment Manager app. Okay. And if you look at this window, you will find out that, I have created so many experiments. That's the reason it is showing me a window over here, which project you want to open. For you, you will not be able to see this recent projects and all that. For you, the option will be blank project. That's the project we want to create from start. I will help you out in understanding how to create the blank project from start, because that is something that will be take away from this particular session. We can start with different examples. One would be to start with a regression example. Another one would be to start with the classification example. Okay. I am going to take both, but just a quick, suggestion from you. Shall we go with classification or regression first? You can use chat box over there. Or we can go with evaluate deep learning experiment by using metric functions. That we can do later on also. Shall we go with deep learning experiment for classification, because regression is also over here. We are going to do that. Anything in chat like regression, classification, what do you feel like?
Yes, sir.
Lots of comments are coming, classification as well as regression.
Okay, so Ankit,
Yeah.
what I'll do is, like I was telling them, we can have classification first. It's easy to understand, and then we can go with regression also. Anyways, we are going to cover both. Okay,
Great.
and
Great.
later on we do have the biomedical part also, so that will be an additional thing. Okay, so to start with, let's click on create a deep learning experiment for classification. So you can click on this, click on open. I hope you all are able to launch this. If there are any problems, any issues, please put into chat. We'll answer that query. Or you can unmute yourself if possible and you can let me know. Shall we move ahead then? Okay. So the name of my, okay. So the name of my project is merchandise classification. I'll explain you what basically this is. So in this, my data set consists of 5 classes: cab, cap, cube, cards, and so on. If I click on this classification experiment, so double click on this classification experiment, it will open up the front window for you. Are you able to see this front window?
Yes, sir.
Okay, thank you, ma'am. If you see in description, we have written, we want to create a project for merchandise image classification where we have an untrained network, which is default network. So it's like we are creating our own network from scratch, a CNN model from scratch. First one. Second, we are using a pre-trained network, which is a Google Net. Done? Okay. What is next? Here, the hyperparameter that I want to focus on is solver, which is SJDM, RMS, prop, or Adam. Later on, we will change certain properties also. We'll come to that point later on, once everybody's done with this. There are no initialization function for us at present, and therefore you may say that I have nothing over here. Right? Okay. Under hyperparameters, we have a strategy which is exhaustive sweep or Bayesian optimization. Now, keeping interest of the participants, I'm not going into detail. I hope this might have been covered. If not, we can connect later on to do this. I am keeping exhaustive sweep. Whichever parameters that I want to experiment with, I will be mentioning those parameters over here. So what are they? Network, solver. Now, if you want to add a new parameter, add, let us suppose this is learn rate. Don't edit this, okay? Please do not edit this right now. Learn rate. I can go over here. I can mention that learn rate could be 1 E minus 3, 1 E minus 5, and so on. Okay. And if you want to delete it, click on whatever parameter you want to delete it. So we will click on this particular row and we'll click on delete. Is everybody okay with this? If yes, let's focus on the template that has been given to us. Right? So what is the template? The template name is classification experiment underscore setup. Where am I going to find this out? So if you drag this window a little bit, you go to the project window, you will find out a file whose name is classification experiment underscore setup. Please let me know if you are able to find out this particular MLX file.
Yes, sir.
Yes. Okay. Thank you. Double click on this file. Don't worry if the experiment manager apps, the experiment manager window is minimized. I'll tell you from where you can find it out. Okay. So you are looking at a template. Now, what is this template? So let me take help of my slides over here. Okay. So this template consists of inputs and outputs. And it will always have a function. Look at the function. What does function has? Function has data, first argument. Second argument is layer. And then what we have? We have options. What are the, so here we have parameters. And I have a function name. Okay. So this is my function name. So if you remember, we have a .mlx file over there by the same name. You can have multiple MLX files like this. And every time what we are supposed to do is we are supposed to, okay, we are supposed to take up this file, as required and as required. We'll come to this part. Okay. Under this, we have the training data. So here you can see this particular part is my training data. In your case, whatever data set you have, you will be mentioning it like this. IMDS train image data store. So it could be an entire data set. So my data is equal to image data store, somewhat like this we are going to write down. Now this particular part talks about splitting, how we have split it up. Right? Okay. Let's go ahead. So we have covered this particular part. Next, let's try to focus on the models that we are going to use. Okay, what are these models? So as discussed, we are going to use two models. The first model is the model that I have created. Don't worry, here you see less number of layers. It's fine. You can increase the number of layers, depends upon you how you write your own CNN model. But anyways, what is the name of this model? In this particular setup function, it is default. So it's like switch case statement over here. Right? So the first model is default. What is second model? GoogleNet. So there is nothing to work when you go with your own CNN model. You can use it directly. The problem is with the challenge is with the GoogleNet. So what are the first things that we are going to mention? If you remember, Ankit and Nikhil have already covered that the input size, how to look at the size of the input layer. For GoogleNet, it is 224.224.224.3. So this is input size. We will define the number of classes, which are 5. Okay. Over here, we are performing some data augmentation because all the images should be of the size 224.224.3. So that's what we are trying to do in this particular part. And you can see I have two parts, IMDS train and IMDS validation over here. What is next? The next is to understand what are the layers in the model, CNN model that you have taken. So if you go to GoogleNet, let me just come out of my presentation mode. Let me go to MATLAB. Okay. If I go to MATLAB, this is my offline version that I'm using. So I will type net is equal to GoogleNet. Please do not do this. This is just for your understanding. Okay. Why we have written those lines. I'm just explaining you. If I go with this net dot layers, it will give me the information of the layers. So at present it mentions that there are 144 layers. Okay. 144 layers over here. Enter. These are the names of the layers. Okay. If you are unable to view this, just let me know. I'll change the setting. I'll change the font size to be 12. Apply. Okay. I hope you are able to view the entire result now. Okay. So if you look at the first layer, this is the data layer. Yes, ma'am, I will answer the question in the chat. Okay. So data layer, this is the input size. If you scroll down and you go to the last layer, can you see over here how many number of classes we have? 1000 classes. Look at line number 142. Can you see over here 1000? Yes. Okay. Okay. Fine. But if you see my data set has only 5 classes. So what should I do then? I need to change certain layers. So what I need to do is I have already taken all the images and set up with this size. So this particular thing, okay, is done over here with this part. I told you that there is a fully connected layer and there is a classification layer, right? So we need to find out these layers, fully connected layer. What is the name of this layer? If you go to MATLAB, okay, go to layer number 142. What is the name of the layer? Fully connected. What is the name of the last layer? Classification output. I need to replace this line number 142 by a new layer corresponding to number of classes that I have. Also, I need to replace this particular layer with a new layer corresponding again to the number of classes that I have. Right? So how this is being done? So we say find the layer. So first we say create a new layer. What is the name of the layer? New underscore FC, where the learn rate factor and the bias learn rate factor should be 10. Okay. And replace this layer by a new layer. So which layer we are going to replace? This fully connected layer, loss 3 classifier. So you see over here, this is loss 3 classifier fully connected. What is next? Next is you have a classification layer over here. Right? Okay. So what we are going to do is we are also going to replace this classification layer. That's what we have done. So under this line number 39 to line number 46, we have modified our layers. I hope this particular part has been covered when you were talking about the pre-trained model. Now someone would say, there is a better way to visualize this? Yes, there is a better way to visualize this. You can go to apps. You can click on Deep Network Designer app over here. Let's launch the app. And here you can choose Google Net. Okay, so here you can choose Google Net. Click on open. This is how it looks like. Okay, you can just zoom in further. Okay, zoom in. I will maximize this to have a better look. Further zoom in. Okay, so click on the first layer on the right hand side. You see the properties 224, 2243. Scroll down. Okay, you have over here, see this fully connected layer, which is 1000. So this is also the way you can find this out, right? Okay, let's close this app because we don't need this. As we keep on working in this particular domain, this will actually help us, gain experience, and then we understood, okay, what we are supposed to do. So just to tell you that whenever you go with pre-trained model, what we are supposed to do is we are supposed to replace the fully connected layer and the classification layer, right? So I have shown you this, right? What is next? Now, if you remember over here, we have to work with solvers, right? So you can see solver. So solver is not mentioned. Usually you mention over here what SJDM and so on and something like that. Okay. So later on, what we'll try to do is we will also try to use initial learn rate over there, and we'll change these values. You can take maximum epochs also. You can take mini batch size and so on. And then it is ended by the keyword END. I hope I have explained you this. Any doubt? Anything you want to ask? Anything which you have not understood? Shall we proceed then?
Yes, sir.
Okay, wonderful. Thank you. So now we need, okay, this experiment manager window. So if you are unable to find out this experiment manager window, on the right hand side, you will find out, if you click on this, there are windows over there, right? Okay. So you can click on maximize and the window gets maximized. Or you can minimize over here. Okay. From here, you can see I have got this minimized. So let me do one thing. Let me close the windows that I don't need. Okay. Experiment manager app. I hope you understand this now. Now you have an option. Now, what are the options? The first thing is to select a default layout. So there's a default layout. If you want to change the layout, you can change the layout. Next, mode. Simultaneous, batch sequential, batch simultaneous. See, if you have a GPU, you can go to other, that is simultaneous option also. Or you can go to batch sequential. So when you go to batch sequential, it will ask you pool size and all other sort of things. Batch simultaneous, I am going to go with sequential. We are going to keep it as simple as it could be for the first time. Now, there is an option over here. Click on run. Right? Let's click on run. And please let me know if you are able to achieve the same result that I am looking for. So you can see that what has happened is that the training had begun. So with the combination, I have 3 solvers and 2 models. So the combinations are 6 combinations right now. Any issues, any challenges?
One not able to locate this. Kunal.
Just a second. Thank you. So sir, you have to look on the right hand side like this. There are windows on the right hand side. So if I minimize this window, let's suppose that I don't know, I am unable to see this window, right? So what should I do? I should go to over here. Okay. And you can see that, I will be able to find out the window. So simply click on restore all. If you are unable to find out, you will get the window. Okay. Any other query? I'll wait.
If anyone is getting any problem, you can share, you can unmute, or else you can share it in chat box. Or else if you are getting an output, you can also reply with that.
I'll wait for a minute for you all to get these results. Anyone who have got the results? Okay, thank you, Swati ma'am.
Yes, others can also let us know whether you have got the results.
This is just a beginning. There are a lot of things that we are supposed to do over here. Okay. Okay. Thank you, Gayatri ma'am. Okay, so I think now it's time when we can go ahead.
Yes, sir.
Okay. Don't worry if you don't get it for the first time, it's fine. Now I want to look at the results because we have seen we run this particular experiment. What if I want to look at a particular result? So I want to find out the model which has the best accuracy. So you have an option over here to sort in ascending or descending order. So I will sort in descending order. I want the best accuracy. There is no change because training accuracy is 100% over here. Training loss, I want it in the ascending order. Minimum training loss. Right? So if you want, we can put it in this way. Sort in ascending order. What about validation loss? What about validation accuracy? So I want the validation accuracy to be highest. Put this into descending order. Right? And accordingly, you will find out that the experiment number 4 combination Google Net RMS prop gives me training accuracy 100, training loss 0.0003, validation accuracy 95, and validation loss is 0.3622. If I want to visualize the results, how I can visualize the results? Select the best model, click on training plot. You would be able to see the training plot. These are the plots. Don't worry, you can resize these windows if you want. You can just resize the window to have a better look. Okay, fine. What about training data? This is my confusion matrix. So I have for both validation also. What about filters? So you can use filters. Okay. Now you can filter something, filter by solver, filter by training accuracy, and sort of things. So see, you have everything over here. Number of trials for solver, training loss, okay, validation loss. So you can go to filters and you have all sort of things. So you can select over here. Okay, you want solver. Select this, right? Okay. And if you do not require it, we'll just close this. This is a trial that we have selected. Okay. What else we can get? We can get validation data. Now, someone would say, I want to copy the results. So I want to copy this result. So resize your window. You have an option over here. If you click on the figure, from where you can copy this. So you have an option, save, and you can save your results here itself. So you can save the result for training. Similarly, you can save the result for loss. If you go to training data, click on the figure, click on save, you can save those results and so on. Okay. And if you want to provide annotation, you can provide the annotation. What we can do after this, if I have got the best model. Okay. So let me look at this. So this is my best model. I want to export this model. So click on this row and click on export button. And you can see I've got the options. What are the options? The options are train network, export the train network. I need the training information or I need the result table. You can do anything, whatever you want. I want the result table. I'll click on result table. So, okay. So it says in workspace, I have a result table. Minimize this. Go to your MATLAB workspace. So if you don't find the MATLAB workspace, go to layout, set your layout correctly. In the workspace, now there are so many variables, right? So at the last, you see result table. Click on the result table. I have the result table over here. So this is my result table. And you'll say, oh, I am not able to see anything. It's fine. Okay, you can see what exactly it's talking about. Okay. Now, since I have 5 models, so you need to click on row, and inside row, you will get, the different result. Don't worry about this. It's fine. Let me just go to home, set the layout correctly, and I may close whatever windows that I don't need. Okay, this was just to show you that you can export the result and you can get it, right? And if you want to look at the results are already there. Just click on experiment manager. So you already have the results over here for all the rows. You can click on show hide and you can choose only those variables that you're interested in, and you can, unhide or hide as per your requirement. Fine. Shall we go ahead then?
Yes, sir.
Okay. So, for this experiment, I have got the results stored as result 1. Now, I want to further modify my network such that I want to use over here ResNet 50. How I can do that? Okay, so go to your script. In your script, are you able to see this case GoogleNet? Right? Are you able to see this? What I can do is I can copy this part over here, enter. I can add a new model over here. And now see it gives me warning because it says there is a duplication. Can I write over here ResNet 50? So what are the changes that we are supposed to do? Okay, that should be ResNet 50. What else? What are we supposed to do? What else? As you can see over here, I'll put, okay. And in the experiment manager, what I'm supposed to do is I'm supposed to edit this, give a space.
The chat box, we have question. We are using two models.
Yes. We were using two models earlier. Now I want to use three models. What I can do? I want to use 5 models. I want to use as many models I can.
Sir, are these model inbuilt models?
So yes, ma'am, this is a pre-trained model. So see, I have just shown you. I have not gone into the details of ResNet 50. So I don't know the location of the fully connected layer and ResNet 50. But let's try to run this and let's try to see if it gives an error to me. And if it gives an error to me, I have to resolve it. If not, as you can see, I have got HUDM RMS proc default. Okay, let me just stop. Let me just stop. Okay, let me know how many of you have been able to do this. Just wanted to understand. I'll just close this. And let me run. So if I get an error, okay, it's fine that if I get an error over there. If I don't get an error, then I need to find out, okay, what might be the reason that I am getting an error. So just wanted to understand how many of you have been able to do this. Please let me know. Are we able to do this? Okay, please try, ma'am. So those who are using offline mode, I'll show you this. So I am repeating this once again, like many of you might have not been able to do this. So go to the Experiment Manager app. So I have so many examples over here. I like to take this example, create a deep learning for classification. And we will go with simpler thing, like instead of adding a model over there, let me try to take the liberty over here and change the learning rate. Okay. So see, we have this window, right? Let us do one thing. So this is the setup function, right? What I'll do is, let me add learning rate. Okay. So I'll keep those windows side by side so that, yeah. So, what I'll do is, can you see it's written over here, initial learn rate. Now I want to replace this initial learn rate. Okay. And I want to take it as a hyperparameter for, for my strategy over here. So how I am going to do that? Add, double click on this. I'll write down, this is initial learn rate. Okay, R is capital. I'll follow the same. Right? And here I want to pass the values. So here I am writing it to be 1 e to the power -3 space 1 e to the power -4. I think we can start with 2, I will say 1 e to the power -2 and 1 e to the power -4. Done. But when I mention it over here, I should remove it from this particular script also. Right? So I'll just remove this. And if I press delete, it shows me error. Nothing to worry. Now this gets corrected. Save, Control S. Okay. I have a window over here now. Where did I mention it? Just a second. Let me close this. Really sorry. I'm supposed to use the offline version, right? Okay. Layout. Okay. Okay. Let me use another window. Okay. So this is my experiment manager window, as you can see. Right. Now, let me click on run. And see, it is possible that you may land into errors sometimes. So we can debug the errors, okay, by looking at what exactly is happening. So now you can see I have got different combinations, 12 combinations. And if you look at the table, what does the table have? I have 12 combinations right now. Okay. You can see initially we were having 9 combinations. So that is how we can modify, the learn rate factor. Okay. And then we can go ahead. Right. Which is shown over here. Any doubt? Okay, instead of this, would this be helpful to you if you do get an opportunity to use this in your research? Any questions? You can unmute yourself and you can ask me if there are any questions.
Sir, we hope everyone is doing with us.
Okay, okay. So we will wait, ma'am, then in that
Yes.
case. Okay, shall we move ahead? So this was the shift examples, okay, with respect to classification. I think we can move ahead to another example.
Yes, sir, yes.
Okay, because after that, we have to work with other example also. So let me close this experiment manager window. Let's close this. You can go to files over here and you can say close the project. Okay. So that's how you can go ahead and you can do this. Okay. Close the panel and so on. And if you find there is any problem, go to home window, click on layout and click on 2 column. Go to project and here we can say close project. Fine. Just close everything. We'll type clear and CLC. Okay. We'll set a layout to 2 column. Now, if we go to, let me close everything. Let me even close the experiment manager app. Okay. If we go to our file that has been shared to you, now this is the exercise that you are supposed to do. As most of you have joined in a hands-on mode. What we are going to do now, we are going to launch experiment manager app. And instead of taking classification example, we are going to go with the regression example. And in the regression example, we are going to focus on the probabilities and we are going to focus on filter. Okay. And you might see over here that a custom metric is added, which is known as accuracy. Let's try to launch this. So go to apps, click on experiment manager app. Click on open. Yes. Do you want to open the current project in the experiment manager? We'll click on yes. Okay, sorry, I did a mistake over here. It should be no. Experiment manager. I'll say no. Project and close project. Okay. Fine. So you can go to apps, experiment manager. My earlier project was open. That was the reason it was giving me, some error. Click on open. So you need to close the project. Okay. If you move ahead. So there will be in project window. Click on that project window, navigate to close project and then open the new project. Okay, fine. Now this is a new project. Let's click on experiment, regression experiment. And you can find out what is the function name over here. The function name is regression experiment setup. Here we are going to focus on metric functions, hyperparameters that are probability and filters. Okay. And I could see there is one custom matrix which is known as accuracy. We don't know what that accuracy is. Okay. So we can do one thing. All of this should be mentioned somewhere, right? So where they would be mentioned? They would be mentioned in the project folder. So what do we have in the project folder? So in the project folder, we have a setup function. And we also have one file, which is accuracy.mlx file. You can click on this and you can say open. Okay, I'll show you this later on. Anyways, let's click on this setup function. So what it says we have taken the same data set that was the handwritten digit data set. We have created the network. But in this case, you will find out that the earlier network, the filter size was mentioned. But when we are going to set up an experiment, we are not mentioning the filter size, right? We'll take it from the experiment. Hence the name params.filter, taken as number of filters, right? Also, are you able to look at this dropout layer params.probability? In the initial code, we have mentioned explicitly that the dropout layer was 0.2. Probability was 0.2. But now we are going to pass it from our experiment manager app, that is params.probability. That's the reason you will not find out over here. Okay, we are not doing anything with respect to the training parameters right now, but if required, you can again export this initial learn rate from here and can put it over there. If you want, I'll show up this to you. Right? Done? Okay. Go to your experiment manager app and click on run. And you can see that the training had got started, right? Okay, so how many combinations are we expecting? We have 1, 2, 3, 1, 2, 3. Okay, so with respect to probability filter, so we should have 6 experiments over here. We can see now. Okay, we have one more parameter over here, accuracy, which is our custom parameter. At the end, we are going to look at what this custom parameter is. Okay, don't worry. Okay, any doubts? Any challenges? Okay, not able to add.
One
So,
query is there.
yeah.
Not able to add regression experiment in experiment manager. Experimental manager.
Okay. So, sir, you might have seen that when you had opened the earlier project, a new project window gets added for every experiment. So you need to first close the project, and then you need to again go to the Experiment Manager app. Okay, you have closed the project. Then you need to go to Experiment Manager app, search for the sample code as shown over here in the script which I have shared. And then you need to click on that. It will get open, sir. Okay, I want to look at the metrics of the first model. So let's click on training plot. So I can see I've got the training plot. So even though when other models are being trained, I may be able to see the visualizations, right? Okay. So what do we conclude from this particular experiment? Okay. So if I look at the result table, and if I look at the last particular row, you might have seen that with probability 1, 0.1, dropout factor, filters 8, I am able to receive the minimum accuracy. So, okay, so let's do one thing. First, let us sort this out. So training RMSE should be ascending order. Training loss should be, it should be ascending order. Anyways, I'll just minimize this. So, okay. Validation RMSE, it should be in ascending order. Validation loss should be in ascending order. Now, if I do this, you might be able to see that, you know, the trial 5, this experiment 5, which has got 100%, okay, is able to give me the accuracy of 97.3000. So can we conclude from whatever we have seen up till now that by using this experiment manager app, we will be able to perform number of experiments?
Yes.
And achieve the results?
Yes.
Yes. So would this be helpful in your research further?
Definitely.
Definitely. So you might have seen some tables in IEEE papers or some other papers where they have focus on hyperparameters, and they talk about filters, size of the filters, they talk about this probability, they talk about epoch. So they are actually talking about this hyperparameter strategy. We can do one more thing, like someone may think of adding a learning rate, like I have shown you to this. But now there is no point in adding that learning rate, because if I go to result, I am actually getting it to be 97.300. So probably that could not be a parameter that I'm looking at. So someone can say, okay, can we go to this? I'll just minimize this. Can we go to this setup function and can look for any other parameters? Right? So see, you have average pooling layer over here. 2 is mentioned. Over here, this 3 is mentioned. If you scroll down, we have epochs. We have initial learn rate. So someone can say here we have taken epochs to be 30, right? Max epochs to be 30. Can I delete this max epochs from here? Go to my experiment manager app. Add over here epoch and mention epoch to be 20, 10, 20, 30. And can we find out if we are going to get 90%, 95% accuracy with a minimum epoch? Minimum epoch actually is contributing to the minimum training time the model is actually taking over here. You can draw the conclusions the way you like. Okay, so if I want to do this, okay, what I am supposed to do is I need to add max apox. I do not want to run this. I'll just write down over here. Max apox. Right? And then you can mention over here what you want the max apox to be. Let me take the max apox to be 15 and 30. So if I'm mentioning max apox over here, I have to eliminate the max apox. So let me just delete this. Control S. Now let's try to run the experiment again. Okay. Now see, the script that has been shared to you already talks about how you can add the hyperparameters. So it's talk about adding the hyperparameters over here. My initial learn rate, my solvers, and then you need to write it like this, params.mysolver. Okay. If you are thinking to add a few more things, you can add it like that. Let me try to run this and let me check if I am able to do this. If I get an error, then probably I am not able to send this particular values to my function. Now see, I have got few more combinations where I have got epochs also. Right? So likewise, we can add as many hyperparameters as required. Can get the best hyperparameters for the desired accuracy and the results. Okay. Any questions you have? Anything that you want to ask? Now now this session is open. We can utilize some 10-15 minutes over here. I am planning one more session in the afternoon to show you, ECG part, ECG and AI. And then there is an example, skin lesion example, which I wanted to show. Any queries, anything you want to ask?
Yes,
Or if
participants, if you have any queries
you
related
may
to
you may have a feedback on this, like you can mention the feedback in the chat also. Will this be useful? What exactly you are looking for if we have a further interaction?
if anyone is working using MATLAB for the research purpose, if you have any errors over there, you can definitely ask. So we have a question in the chat box.
Is there are some tutorials? Yes, sir, definitely there are documents. I will try to download the documents and will share it in the folder so that ma'am can share it to you. You can do one more thing, like you can go to MATLAB videos. So MATLAB videos are also a place where you will find out some resources to get started with. Okay, so you can type over here experiment manager. Okay, let me yeah. So you can see, see you will get links like this. Managing and fine-tuning portfolio optimization workflows with experiment manager. And then all such videos are available. So this is with respect to the MathWorks video that are available online. And if you're looking for some documentation, I have already shown you how to access the documentation. Okay. If you want, I'll share this link later on after the session. So I hope the session was useful to you, whatever we have done in the first half. So ma'am, can we conclude this particular part over here, as we will take one more 1.5 hour session.
Yes, sir. So at what time we will start the session so that
We'll start at 1:45, ma'am, so that or you, it decides like where you want to. If we can start with 2 also, 2 to 3:30.
1:45 is fine, sir. We will go with the session 2.
Okay, so I will share link with you. Would be a Teams link,
Okay, sir.
because there are 2 parts that we need to cover. The first part will be experiment manager for skin lesion, and then another part will be use of AI and ML for ECG signal. And then we are asking the users to do experiment manager exercise on the ECG part. Okay.
So dear participants, we will be having a session 2 at 1:45. We will be continuing with the session after the lunch break. So you are requested to join on again. We will share the details related to the session, and the feedback link will be shared after in the session 2 itself. So see you again. Stay tuned.
Yeah. Thank you, ma'am. Thank you, dear
Thank you,
participants.
sir,
Let's
for
meet
the
again.
session.
Yeah. So, ma'am, I'm leaving the meeting. Okay.
Yes, sir. Yes.
Yeah.